The broadcast is now starting. All attendees are in listen-only mode.
So good morning, and thank you for joining us for the second webinar of our ongoing webinar series in regards to municipal concrete paving. In our first webinar, we introduced the Municipal Concrete Paving Guide, which is a free document available on the Concrete Ontario website. It's also part of your handout section on the right side of your screen if you want to access it. We provide an overview of the status of concrete pavements in Ontario. Then we showcase the many benefits of concrete pavements. We also provided some basics about the structure of concrete pavements in the last webinar. And then finally, we looked over a whole bunch of different applications where concrete makes sense. And they're all local projects in Ontario that have been done in the last 4 to 5 years. Now today, we will dive into the construction aspect and exactly what the procedure is to build a concrete pavement in a municipal setting. So my name is Alan Carey. I'm the Director of Technical Services at Concrete Ontario, and I will be your facilitator this morning. In terms of housekeeping, just for individuals who've joined us for the first time, so this will be approximately a 45 to 50-minute webinar with questions and answers at the end. All participants are currently muted and will remain that way for the entire webinar. If you do have a question, please use your GoToWebinar questions pane on the right side of your screen and type in your question. We will address all questions at the end. The webinar is currently being recorded and will be posted on the Concrete Ontario website along with a PDF copy of this presentation. The link will be sent to all participants either later today or tomorrow morning. Now, if you did miss webinar number 1, which was the introduction that I just mentioned to municipal concrete paving, no worries. It is now available on the Concrete Ontario website. The same link where we will be posting the new recording and the new PDF presentation. So feel free to access that information and let us know if you do have any questions. In terms of today's agenda, so we will review the concrete pavement structure again that we mentioned in the first webinar, just to give you a refresher. Then we're going to get into construction site preparation, looking at preparing the subgrade and placing granular material. Next, we're going to get into the different paving options when it comes to municipal concrete pavements. So there's fixed form and slipform paving. We'll show you some advantages and disadvantages of using each one. Then we'll get into concrete mixing, transportation, placement, finishing, curing, and jointing as well. And finally, we'll finish off with some requirements from OPSS in terms of opening the pavement to traffic. You know, what do you need to consider before you're allowed to put traffic back onto a concrete pavement, a reconstructed concrete pavement. Now, just to highlight again, today's presentation will be focused on all Ontario projects. It is based on Ontario standards. We really want to drill in on what Ontario is doing, and that is our main priority when it comes to this webinar series. Now, in terms of your presenter, I'm joined again by Tim Smith. He's the Senior Director of Built Environment, Transportation and Public Works from the Cement Association of Canada. Tim doesn't really need an introduction. He's been in the industry for over 25 years. He's worked for ready-mix producers, consultants. So Tim will be the presenter, and he will be providing all the information in today's webinar for you. And then we'll save all the questions till the end. So good morning, Tim. How are you?
Good, Alan, and you?
Can't complain. It's a beautiful day. Looks like our turnout is pretty good here. So I'll turn it over to you here, and you can start it off.
Thank you very much, Alan. Good morning, everybody. I hope everybody's doing well and keeping safe. Today, the first couple of slides, I'm going to be going over are kind of a bit of a review of the let's see if I can get control here. It's not changing here, Alan. There we go. So the first few slides are actually going to be looking at the presentation that we made last month on the municipal concrete paving side. Then I'm going to be, so first thing I want to do is kind of really to look at the pavement structure. Just this is just to compare the asphalt versus concrete. Just to show you, a concrete pavement structure is thinner than an asphalt structure, and that's due to the way the concrete pavement takes the load. Most of the load goes in the concrete itself, so less stress goes down into the base and sub-base layers. And then asphalt is a flexible pavement. The layer, most of the load is transferred down on the base and the sub-base, so that's why you see a lot more sub-base on an asphalt pavement. Now, one of the key things here on 400 series highways in Ontario, for high volumes, MTO requires an open graded drainage layer underneath it. I'm not a real big fan of them, but if you have them, there's a couple of things you want to make sure you consider. That it's going to change the effective thickness of your pavement, because there's going to be a small amount of the paste and the fines that will penetrate down into the open graded drainage layer, because it is around the 25% void ratio. So what that's going to do is it's going to change the effective thickness of your pavement. So when you do your joint cutting, you may end up having to cut a little bit deeper, maybe 10 millimeters more. Because of that, you have to make sure that you're very careful not to go down and hit your dowel baskets. That would be one thing. The other thing is, because you're getting a really strong friction developing and the concrete itself is just gaining strength, you're going to have to get on and cut that concrete quicker, because if you don't, the strength of the bond between the open graded drainage layer and the concrete is going to exceed the strength of the concrete, and you'll get some random cracks occurring. So those are just a couple things that you have to take into consideration. So the next slide is just to kind of review what are the key components of a concrete pavement. Well, we learned in the Municipal Concrete Paving Association there's a big difference between a tie bar and a dowel. Tie bars are deformed 15M, 750 millimeter. They get ribbing on them, and there's no oil put on it, ductile put on it to prevent a bond. You want the concrete to bond to that, and you're going to end up having a situation where that you allow this concrete here to bond so that it will not allow the longitudinal joint to drift apart and become a maintenance issue. Dowels, on the other hand, are 32 millimeter, 38 in thicker pavements. They're smooth, round. They have a ductile material placed on it to allow the concrete so it doesn't bond to it, so it can actually have concrete expand and contract in the different seasons. Very different. It's also much thicker, and it's used for load transfer from one slab to the other. And of course, you get your transverse joints. They're cut in to prevent random cracking, and longitudinal joint delineates the lanes, but also allows you to have a crack that's not random down the center line. Another thing with concrete pavement too as well, you have a situation where you usually have less granular material. If you're on a high volume highway, you will have a base and a sub base, but if you're on a lower volume highway, you're probably only going to have a base aggregate for a working platform and a drainage layer. So some of the key documents that are important when you're looking at concrete pavement construction are the OPSS documents. And we like to use the OPS Muni documents when we're talking about concrete pavements in the municipal environment. They're written for that specifically. Now, the OPS 350 is a construction specification for concrete pavements and concrete bases. That document is 1998, is actually under review, and it should be released sometime this year. We're hoping, if all goes well, so that it'll have more up-to-date clauses in it to keep in with the CSA 23.1 and other different clauses that have changed over the time. Then we have the 314, the 501, the 1350, all very important documents when you're looking at the construction aspects, the compaction aspects, and looking at the materials. Now, another one that we look at too is the OPSSD. That's the Ontario Provincial Standard Drawings. There's drawings for utility installations, there's drawings for jointing details, load transfer devices for the dowel baskets, tells you the distances that you use, the depths for saw cutting. There's also composite pavement utility isolation drawings in there, concrete barrier, curb and gutter. A lot of different documents in there, but we can't go over them all, of course. So these are the foundation for your construction and the things that you're supposed to do when you're doing a concrete pavement. So what we're going to first look at is site preparation. It's extremely important when you're doing a concrete pavement to have a uniform base. Doesn't matter whether you're uniformly strong or uniformly weak. If you have a base that's consistent, then you'll get your best performance. If you have different types of soils, what you're going to be doing is blending the soils between doing a transition so that you don't have abrupt change in the strength. So the key to performance is uniformity. You're going to have a geotechnical investigation. You're going to know the soil type, and you're going to know the moisture contents and the densities that you're going to be working with. And you want to remove any unsuitable soils. If you have some clay type soils that have a high PI value, that plasticity index that you want to change, you can actually use a hydraulic road binder, a cement or a blended cement that will allow you to stabilize that and make it change the properties so it can be used in your project. You also want to follow the proper compaction process. The MUNI 501 will tell you about that. And of course, you want to build to these tolerances that are specified in your tender. So when you're looking at this, just a brief explanation on cement modified soils. What you're trying to do here is, if you have a subgrade that is not in spec, you can actually modify the plasticity index through adding hydraulic road binders. You can look at the volume change can be that's caused by the moisture. You can reduce that. You can improve your wet strength because you're actually combining the clay particles together to provide a stronger working platform. When you're using a hydraulic road binder, you also have a permanent fix. So what you've done to enhance the subgrade, that will be a permanent fixture. Now, when you're doing this, you have to realize that your resilient modulus of your subgrade does change, but it only changes to the depth that you do your stabilization, which is usually 300 to 400 millimeters. So what you want to do when you're doing your analysis is consider if the material is deeper than that, you want to look at doing a blended resilient modulus value so that you don't use too high of a value when you're doing your analysis in pavement design. Also, you get limiting muddy construction areas and all-weather working platform. Now, when you're doing this, you're using the 5 to 3% range because you're not really trying to increase the strength of that subgrade so much that it gives you a much stronger surface layer. The one key thing is, if you're dealing with sulfate soils, you want to use sulfate-resistant cement, or you want to use a blended cement, which will allow you to function in a sulfate environment. So what are you doing? You're preparing the grade now. So the first thing you're looking at is you're going to make sure that you have the optimum moisture content to give you best density for your subgrade. And as I mentioned earlier, if you have varying types of subgrade that you're dealing with, you want to do a transition between those areas to ensure that you don't have an abrupt change or a dynamic load in your pavement in that location. After you've prepared your area, you then want to proof roll it. You can proof roll it using a 10-ton vibratory roller, just driving it over that will identify any soft spots, or a fully loaded dump truck will actually act as a great proof roller so that you can determine where your soft spots are. When you have soft spots, you want to remove them and replace them with material that's similar to that of the native soil, or you can possibly do a stabilization of that material as well to get the properties sufficient to be able to use in your project. The final step is your profile grade. And when you're doing this, you're going to look at if you have a situation where your subgrade has the possibility of fines migrating up into the new granulars that you place on it, you'll want to put a geotextile down, and that will prevent the migration of the fines, which would contaminate your granular base and subbase layer over time, and would change the performance of your pavement because you're now weakening the pavement structure underneath it. So it's critical to have an engineering firm go in and do a detailed evaluation of what your subgrade material is, the types, the moisture contents, the densities, and determine whether you have a water table that's going to allow that migration of the fines so that you'll have a good performing subgrade. Now, the next thing that you're looking at is your granular material that you place on top of it. And as I mentioned earlier, when you're on a 400 type series highway in Ontario that has higher traffic levels, you may have actually granular base and subbase both. In your lower volume traffic areas such as municipalities, local roads, things like that, you may only have a granular base layer to deal with. When you're doing a subgrade compaction, The specification, OPSS specification, talks about being at 95% maximum dry density. Here, when you're looking at your subbase or your base layers, you're looking at 100% maximum dry density compaction. Also, when you're placing these, you don't want to go over 150 millimeters of compacted material. So if you've got 300 millimeters of granular base that you're going to be placing, you've got to do that in 2 layers. You don't put the 3 layers, put 1 layer in and compact it, because what may happen over time is the vibration of traffic over the pavement may actually consolidate that material more and cause a gap underneath your pavement. And with concrete pavement, the key thing that you're looking for is uniformity of your base material and your subgrade. So you want to ensure that you put these thinner layers and compact them appropriately as identified in OPS Muni 314. Now, another key thing to do just before you start paving, you want to actually place water on the surface of the aggregates if they're dry, because you want them saturated surface dry so that you won't take the moisture out of the bottom of the concrete, which may actually not get complete hydration of the cement at the bottom of the concrete, and you'll end up with a weaker concrete than you designed for. So that's a key thing to do when you're looking at the pavement. Now, again, you can actually stabilize this material with cement. It's a common practice when you're doing airport operations, but not something that you see a lot in municipalities. It is done when you're using a chip seal type thing, but when you're using concrete in the municipal environment, you don't usually see a lot of cement modified soils being used in the aggregate side. Now, one of the key things, once you've finished your compaction, you want to do another proof roll again. But you see here in this case, you actually have a surface that actually has got some rutting from the traffic operating. Now, what can happen when this happens? If you place concrete directly over top of this, you'll actually get some volume changes in your concrete, because your concrete's going to flow into the dips in the pavement in your aggregate structure. So you're going to have an overrun on your concrete. But not only that, if those ruts are deep enough, you can actually prevent your concrete from shrinking as it's losing its moisture. And then what you're going to do is possibly cause some longitudinal cracking. So you want to make sure that you have a good performing granular base that you're placing on, and that you don't have issues with soft spots, which are going to be removed, and you don't have rutting built into your aggregate base. So the next one we're going to look at is fixed form paving. So when we're looking at fixed form paving versus slip form paving. So we're going to look at fixed form paving first. So when we're doing some fixed form paving, you'll notice here that this time they've used wood as the form. On the left-hand side, you'll see curb and gutter. So that is one edge. And on the right-hand side, you'll see the wood forms that are actually nicely braced. One key thing, if you're using wood, you have to use a form release agent on the wood to ensure that when you take that form off, it doesn't have a bunch of the paste bonded to it, and you pull it away, and then you get some honeycombing type look on your concrete pavement. And I'll actually show you a picture of that shortly. So what are the advantages of a fixed form operation? Well, staging requirements are minimal. This is when you're doing smaller jobs that you don't want to bring in a big slip form paver for. It's applicable to any shape or core. If you have islands that you have to work around, if you have obstructions that you have to work around, this will be a very easy way to do that by doing the fixed form process. You have minimal mobilization costs. You've got your form work that you're doing, your bracing. So there's not a whole lot of things that you have to bring to the job site. There's minimal cost for equipment. You actually have an area that is very familiar with a lot of people that do concrete work, because sidewalks are put in all municipalities, so that you'll have a lot of contractors that have the capability of doing that. And you adjust your slump, can be adjusted to suit the needs of when you're doing the placing. Now, some of the disadvantages would be you have more labor-intensive process. You have an increased risk for improper placing, consolidation, finishing, and curing, because instead of a machine doing that, a lot of the work is being done by hand. So you're relying on the workers to be knowledgeable. That's why we recommend the flat work finishing course that's put on by Ready Mix Association. Also, you need 2 edges are required because you don't have a stiff mix that's going to be able to not slump and cause some edge slump. It's a slower process also because you're getting the deliveries made by ready mix trucks instead of a dump truck. So there are some disadvantages here. So I mentioned before, you get 2 edges. Here you'll see on the right-hand side, we actually have a metal being used. These are steel forms pinned down to the subgrade, to the base, I should say. And you'll see we're using an integral curb and gutter on this side. So in this case, you've got, putting the release oil on the metal is not required because you don't get that sticking like you do with the wood. So when we're looking at this, you'll see that what they've done for this design is they've actually drilled tie bars that are spaced at 600 millimeters apart into the curb and gutter so that you can have an integral curb and gutter with the pavement. What this does is it allows the designer to know that there is no edge load because you're utilizing, transmitting that load into the curb and gutter as well, so you can actually have a little bit thinner pavement structure. So you take that into account in your design. These are grouted in. Now, one thing about, when you're looking at tie bars, unlike dowels, if they're out of orientation a little bit, it doesn't matter because the whole purpose of this is to have the concrete bond to them, as you see the ribbing on it, so that the pavement becomes integral with the curb and gutter. Now the next thing is the dowel baskets. Dowel baskets are placed at the transverse joints, and what those do is it allows the load transfer. If you took part in the first webinar, the load transfer from one slab to another is actually transferred using the dowel, so that instead of having a monolithic one slab and another slab, you have the 2 slabs acting together, transferring the load. So it actually allows you to thin up your pavement structure. The dowels are placed half over each slab. And you see in the subgrade, you see the red line marked. That's where the dowel basket is placed. You have, when you're looking at the OPS spec, it allows you 15 millimeters plus or minus away from that center when you're putting your dowels in. The dowels are 450 millimeters long, 32 millimeters in diameter. So that allows you to have a bit of play. Now, when you're looking at the orientation of the dowels, OPSS spec also 350 talks about the position of the dowels up and down is plus or minus 6 millimeters. So you need to follow the specifications in that. You also want to make sure that the dowels are perfectly in the orientation. You don't want them tilted because if you do, you potentially will lock your joint. And you see they even have the lines marked for the next lane that's going to be done after this one. And what's going to happen is one edge of the pavement is going to become the edge of the next pavement lane that's going to be done. So here's a typical setup if you're doing 2 lanes at the same time. You'll see that they've actually marked the center line. They put their tie bars right here. They're on chairs so that they're placed at 1/2 the depth of the concrete. The dowels again were the transverse joint. So this is a longitudinal joint along here. Transverse joint along here. You have the dowels placed. You notice that there's no dowels over here where it's the center, because you don't want a dowel at the center of the. And so you see the edge of the formwork. And again, these are wooden forms, so you're going to have the form release oil on that to make sure that it doesn't bond. It doesn't pull away some of the concrete when you pull the forms away. So one of the key things you have to make sure is when you're doing OPSS 350, identifies that when you're placing your dowel bars, they need to be 600 millimeters apart. You'll see here where they have the dowel basket and the tie bars together. So the tie bars can't be placed at the joint where you have the dowel baskets. That's going to lock that joint, so this joint here would not perform properly. So you have to make sure if you see something like that, what they'll have to do is cut those tie bars off so that they don't impede in the performance of the dowel baskets to allow the concrete paving to expand and contract. So the next one here is just showing the utility isolations. It's important when you have an immovable object, so to speak, a manhole, you want to isolate that and then you want to joint that properly. OPSS has a spec 551.032, and it shows you how to go about isolating. You can put your isolation joint around the manhole. That's a fiber board to allow the pavement to move. There's various types. There's telescoping manholes too as well that can be done, but this is the OPS 551. It doesn't talk about that. Then you do the isolation of your adjacent catch basins as well. So you have guidance that's provided by OPSSD drawings. But also, if you have a series of the manholes, you can actually readjust your joints, think like a crack, and it'll allow you to have a better performing pavement because you're actually bringing your joints into where that obstruction is, because that's where the cracks are going to occur anyways. So when we're looking at slipform paving, so that's fixed form paving now. So it's a fairly simple process. The amount of equipment that's required is minimal, but you have a more labor-intensive crew. Here we're going to go on and talk about slipform paving. These are for higher production areas. And you see here, there's your slipform paving machine. It's a very high production, and because of that, you're going to actually deliver the concrete in a little bit different way as well. So what are the advantages of slipform paving? You get consistent placement and consolidation. You have that slipform paver if you have the vibratory spaced at the appropriate distance and at the appropriate depth, which is done by the manufacturer's recommendations. You'll get consolidation of the concrete, the total depth of the pavement well consolidated. You're going to have an increased rate of pour because you're actually going to be able to handle a lot more concrete at the same time because the machine is doing most of the work. You're going to get an enhanced profile for the construction. You get a flat, more level surface because the machine is doing this, and then you're doing your low floating, the highway scraping straight edge to make it even smoother. In your simplified process for texturing as well and curing, because you normally have a burlap drag behind the machine, and you have a device that allows you to do the curing, so it's much faster production. Your disadvantages is your staging and mobilization requirements are certainly significant because of the equipment that you're bringing on. You must be constructed in lanes because you're paving with the machine. You also have to do handwork. If there's areas where you have islands that have different configurations, then you'll have to do some handwork on this as well. You have an increased cost because you're not going to have your ready-mix trucks delivering the concrete. It's going to be dump trucks and you're going to have that paper. And you also have fewer contractors have the equipment to do this. But in Ontario, we're lucky we have several contractors that can do slipform paving, but it is certainly less than the people that can do the fixed form paving. So again, you'll see that here we have no edges. So what happens is the mix is actually stiff. Usually the water cement ratio in the Class C2 exposure is usually 0.45 maximum. When you're using the slipform paver, you're around 0.4 to 0.42 water cement ratio, water cementitious ratio. So you have a much stiffer mix, so you don't have to worry about edge slump in forming the pavement. It will actually give a very good edge shaped by the slipform paver itself. Again, if you're doing slipform paving, you're using a side loader here to provide the concrete. You can put the dowel baskets and the tie bars in place. They're pinned to the ground. We'll see here, this is a close-up of the dowels, and you'll see pins right here in the areas around with the red. These are pinned to the base aggregate material, or if it's an open graded drainage layer, pinned to that. What you're doing is you're making sure that this dowel basket, when the head of the paving machine comes over it with the concrete, is not going to displace those dowel baskets, lift them up, move them, change the orientation. They're going to be stay in the same place so that the orientation of the dowels is going to be right. Now, another option to having dowel baskets is to actually have what's called a dowel bar inserter. And you see the left-hand picture here shows you a dowel bar inserting equipment, and they're loading the dowel bars onto the equipment so that the person operating the paving machine can put those dowels into place, and then the machine loads them, puts them in the right 300 millimeter spacing, and vibrates them down into place. Because this is a very stiff mix again, the 0.42, maybe down at 0.4, these dowels will stay exactly where they're vibrated to. The vibration process allows the concrete to totally flow around it so that there's no gaps over the top or in the bottom of the dowels. Very efficient, fast process, saves a lot of manpower in trying to place the dowels themselves. So here, we'll now go to the transportation of the material to the job site. You'll see in this case it's a fixed form paving operation, and they're able to back right up to the job because there's no dowel baskets in this job. Otherwise, they'd be doing side loading. And again, they've got the wooden forms well staked to ensure that they will stay in place. So what's key here in the transportation of the material, the production and the placing of it, OPSS Muni 1350 has a batching plant process. The batching plants and equipment are to be certified by the Ready Mix Concrete Association of Ontario, or what we call now is called Concrete Ontario. So Concrete Ontario they have certified 270 plants certified in Ontario. And if you want to go and get a list of what plants have been certified, there's the URL for you to go and take a look. They will go and certify the plants, and they actually certify trucks as well to ensure that they're going to be operating properly and that the fins are in good condition. So it's a very important process to ensure that you have certified plants providing that material so that you'll meet the specification, OPS Muni 1350 specification. So another thing in the municipal specifications, concrete requirements of pavements are identified in OPS Muni 1350 as well. The performance requirements are in 502.02. And then 1350 directly references CSA 823.1. And it's important to use CSA 823.1 because that will tell you the class of exposure and a number of other issues, which I'm going to show you right now. So we know that for concrete pavements, it's a class C2 exposure. It's non-structurally reinforced concrete exposed to chlorides and freeze-thaw environment. So because of that, CSA specifies certain minimums or maximums. The maximum water cement ratio is 0.45. The minimum strength is 32 MPa, specified strength at 28 days, and it's an air category 1. So when you're doing your analysis, your air is actually affected by the size of the aggregate. The smaller the aggregate they have, the more paste that you have in your mix. So the more paste you have in your mix, the more air entrainment that you'll have to ensure that you have a durable concrete. When you increase the size of the aggregate, so we'll see here to the 40 millimeter, you can see that there's a decrease in the amount of air that's required. Because again, there's less paste because the aggregate's larger, it's taking up more of the volume. There's less paste. Less paste means less need for air entrainment. And if we went into greater detail, which we really can't, don't have the time, there's a shape factor and a spacing factor that is done through the air entraining to provide you with the most durable concrete. So it's very important to have that air entraining. Mixes, again, when you're looking at the concrete mix for the transportation, placement, finish, and curing, OPSS 350 has the following requirements. And the 7.03 actually says it's got to be placed as near as the permanent location as possible. Placed at or near its permanent location. So it's very important that you provide concrete directly to the job site. And also, when you're doing this, you can see that the dowel basket is actually already in place. They're utilizing the ready-mix truck to deliver that concrete, and that will be delivered on top of the dowel baskets as well. Now, when you're delivering the ready-mix, you want to make sure it has no segregation and it's thoroughly mixed in the unit. And I just mentioned earlier about the need to have your ready-mix trucks inspected to ensure that the fins are clean and make sure that they are not worn, because the better the fins are, the better the mixture that you get when you're doing your pavement. It gives you a better consistency. Now, what's also important in the 1350 is the delivery of the material. There's a time that you have to discharge and mix and discharge that material into the place, and that's 1.5 hours after introduction of the mixing water, except for when you have higher temperatures. When you have a higher temperature, the concrete will be discharged within 1 hour. And again, you have to look at this from a practical point of view. What is the environmental conditions that you're dealing with? And do you even have an hour if you are having a very fast set because of very hot weather? You'll have to go into hot weather concreting techniques. So when we're looking at ready-mix truck delivery versus a boom truck, if you have no impedance to delivering the material, a ready-mix truck is fine to deliver your material. See here we have vibrating screed that's being used to consolidate the concrete. Then you have the ready-mix truck providing that material. Another way to do it, here they've got quite a width that they're dealing with, so then they can do a side load via boom truck, so that they're providing the concrete that way. Either one works. So I like the Vibratory Truss screeds. They're a very good device for consolidating concrete. They can span 2 forms at a time. It's used in the single or double lanes. String lines or pulleys and cranks are used to propel it, so it's a very versatile machine. The surface vibration is used to consolidate the concrete, and it's done in a single pass. I'll be showing you a roller screed here, and that's actually does a number of passes. Now, one key thing to note is that vibrating screeds are very good for shallow depths, but when you have a deeper concrete, you actually have to provide some additional compaction, which I'll be talking about shortly. So here's an example of a vibrating screed truss screed. So you'll see that they're doing some finishing at the edges here. They've got the people providing the concrete by a ready-mix truck, and they're spreading the concrete around with the come-alongs so that they can make sure they don't segregate the concrete. Very good process, and they've actually got the timing process going fairly quickly behind the truss, so they've got a very low water cement ratio in this mix. Very good operation here. Now here's just an example of the truss working. You can see how well it consolidates the concrete, and they're doing a little bit of smoothing the surface, as you saw in the background, to take out any potential defects that might occur. Very fast, quick operation, and it's a single pass. Now, another option to the vibrating screed is what's called a roller screed. You'll see here that there's 3 rollers. These 2 rollers are static. They're used to compress the concrete. The third one is rolling and it's vibrating, so that's actually what's giving the consolidation. This gives you the level concrete, and the third one actually it spins and vibrates to give you that consolidation of the concrete. You'll notice here, though, that there's a gentleman here with a pencil vibrator, and that's a very important process, because what he's going to do is provide some additional consolidation of the concrete prior to the roller screed itself. And here's just another showing the operation of the roller screed. See, these two are stationary. The one back here is spinning and vibrating. So it's helping consolidate the concrete. These ones are leveling the concrete out. So for looking at consolidation, we're looking at, again, OPSS 350 in the section 70301. Gives you information on the consolidating of the concrete. Now, as I mentioned earlier, here they're providing the roller screed, but they're giving additional. The concrete's being supplied by pump truck. This guy here is standing here with the vibrating pencil vibrator. And what he's going to do some additional consolidation of that concrete prior to the roller screed acting on it. Now, this is extremely important to use this device properly. You're going to ensure that it is put in vertically, not at an angle. You're going to make sure that it's not dragged from one spot to another. It's put in the concrete and then brought out, 15 seconds, put into the concrete again. You're going to be vibrating, especially along the forms to ensure proper consolidation here. And on both sides of the dowel baskets. Another don't is you don't touch the sides of the formwork because you're going to cause some potential segregation here. And you don't touch the sides of the dowel baskets or the dowels themselves because that can provide some segregation as well. And you'll get some honeycombing and you won't get complete consolidation around the dowels themselves. So very important to do that additional consolidation. Check and see how we're doing for time, 20 minutes. Okay, the next thing I want to look at is the placement. Here's a fixed form placement and it has a joint cut. This is a very good joint cut and it's cracked right where that joint is. Another one as well, it's cut right where that joint is. However, in this case, we have a couple of issues. Here, this could have been an issue with, again, the forms not having the form release agent placed on it, and it took away some of the paste and fine aggregates. Or it could have been they touched the side of the form and ended up getting some honeycombing, some segregation in this area. Same thing here. We got an issue with, especially around the dowels. There's a lack of consolidation around here. What's going to happen that over time, with the loads, these dowels are going to be moving and they're going to deteriorate the concrete around them because there's not a sufficient paste content here. And it's going to decrease the life of those dowels themselves. The pavement load will be decreased. So when we're looking at fixed form paving finishing, it's important that you know the magnesium bowl floats, they should be magnesium or aluminum. They should not be wood. If you have air entrained concrete can actually have, you can tear the surface and you'll get a surface that doesn't look very good. Another thing is very important, you do not add water to the surface. If you add water to the surface and use a bow float, the bow float is basically adding that water to the surface, changing the water cement ratio in the area that you want the most durable concrete. You're now going to have a weaker concrete because you've got excess moisture and excess water in that area. You change your water cement ratio from probably 0.45 up to 0.6 or whatever, which means you're going to decrease the strength of the concrete where you want it to be stronger, going to make the pavement more susceptible to scaling. Here again, we see the bowl float operation. The bowl floats actually just smooth out the surface. It's different than the highway scraping straight edge, which you see here. Bowl floats can only do a bit of smoothing of the surface and do minor corrections to it. What the highway scraping straight edge does actually, it actually will take off high points and fill in low points as it's being moved and scraped across to give you a very flat surface. This is actually what's used when you're doing a super flat floor. You'll use the highway scraping straight edge to do the work. I really like these because they provide a smoother, better concrete. Sometimes they'll actually use the two in conjunction, use the bowl float first, and then they use the highway scraping straight edge afterwards. Talk about surface texturing. It's important to provide texturing on concrete pavement because that allows you to improve the skid resistance and the ability to drain water from the surface, so improves your hydroplaning capabilities. The common forms are broom finish, burlap drag, or it could be an astroturf drag. transverse tiling, longitudinal tiling, and diamond grinding, of course. That's used sometimes in new projects where they don't want to do any highway scraping, straight edge, etc. Things like that. They can actually just diamond grind the surface right off the bat. Or when you're doing rehab on a older concrete pavement, you can use diamond grinding. So OPS 350-733 has information on texturing. Concrete shall receive an initial and final texturing. The initial texturing is a burlap drag, which is done behind the paving machine. If it's a slip form, but a fixed form, I'll show you a picture of it. You have to do a burlap drag. And why do we do that? There's two things. One, there's a micro texture and a macro texture. The macro texture are the grooves that you put in the concrete. And these grooves allow you, when water's on the surface of the pavement, when a tire comes and drives over it, it'll take the water, push it into the grooves, and take it away from underneath the surface of the tire. So your pavement tire interface is better, so you have less chance for hydropumping. The micro texture is the top surface here. This is when you have the burlap drag that roughens up the surface, and also has where you have your paste and your fines. And the manufactured sand gives you the best skid resistance because it gives you more angular material. So OPS S350, as I mentioned, is the one that we're looking at. Burlap drag, here what they're doing is they're getting the burlap ready. It has to be wet to be put across the concrete so that it has some weight so that you will actually get some roughening of the surface. You can see here what they're doing is they're placing the burlap drag over top of the concrete, and they're getting a roughened surface here so that you'll improve the skid resistance of that pavement. Now the texturing process, the finishing, fixed form, a lot of times what they'll do is they'll use a broom that has a wire spaced at a certain spacing, 3 millimeters. They're 3 millimeter in size, plus or minus. The width, the distance between them is 16 millimeters. So you look at this type of broom is used to put a grooving into the concrete. And you'll see here on the right-hand side, this is the grooves that you're getting from running over top of the burlap drag area. So you've got your nice surface texture for your micro texture. You're now putting your macro texture in by dragging the broom across it. The grooves, the deeper these grooves, the louder your pavement. So you want to stay within specs. Deeper is not better. Stay within the specs itself. It can't be too shallow because it will wear off over time. But it can't be too deep because that'll increase the your noise level. And here we see a good operation, the macro texture being put in, the broom, the burlap drag has been done, and there's a broom finish that's being done. Now, an alternate texture, instead of doing a timing where you have the grooves at your lower speeds in the 50 km/h, sometimes maybe up to 70, you can actually go through and use a broom that is more like a bristly type of broom instead of having the grooves that you put in the concrete. And it gives you a very rough surface, gives you very good skid resistance, and it provides you with, at your lower speeds, a very good surface to deal with. Of course, you've got the crown of your pavement, takes the water away from the surface anyways, so you provide good skid resistance. And this is just another picture of an alternate surface. Now this is with microfibers. You see it's a little bit rougher surface because the fibers are being brought to the surface. And in this case, an alternate broom surface. Went the wrong way. So next thing is curing. So when we're looking at curing is extremely important in concrete. If you don't cure the concrete, you're not going to gain the strength that you were supposed to in the design. You'll dry out the surface, and the concrete's going to be weaker at the surface, so it's going to actually lead to scaling of the surface of the concrete. So you want to make sure you use your curing compound appropriately. I like the white curing compound because it actually allows and shows you the application that you've done and if you're getting complete coverage of the material. You want to follow OPSS Muni 904 when you're looking at curing. You'll see here, look how well this is being placed. It's very good coverage. You don't have any spots like this. He's covering that up now so that he's going to have a concrete that's going to retain that water in it. It's going to get complete hydration of the cement, so you're going to get the strength gain that you want, and you're going to have a very good, strong, durable surface as well. The curing shall be applied to all exposed surfaces as soon as you're finished texturing. Now, one thing you have to make sure that when the forms are taken off, you're going to actually go through and put curing compound on the sides. Here, you don't have to because you get sidewalks as part of it, but if this was an exposed area, you'd have to put curing compounds on the side to keep that moisture in the concrete. Here again, we show another one, fixed form paving. You've got your steel forms here, and the curing compound is being placed, and look at the final product. It's flowed into the grooves that they put into the pavement. Very good looking curing operation here. Now, concrete mixing and transportation, when you're looking at slipform paving, you're going to have something rather than a ready mix truck. Because the production is so high, you're actually going to use a dump truck. So when you're using the dump truck, the concrete is completely mixed in a stationary mixer or a central batch plant that's near the job site. It's dumped into the dump trucks, and then you have 30 minutes to get the material in place and discharged. But normally they'll set these up very close to the job site, so that should not be an issue. And here you see the slipform pavement process. They're getting the side delivery. They're delivering the concrete as you're going here into a side delivery machine, and then you have your paving machine over here, as you'll see. So this is a very fast process. The dump trucks are coming in, dumping the load, pulling out, new dump truck comes in. So you get a continuous flow of material into the slipform paver so they can have a continuous speed and you don't have stopping and starting. When you haven't stopping and starting in your slipform pavers, you'll actually have the pan will collapse and then you'll actually have a dip in your pavement. And when they start up again, it'll actually, the pan will rise and you'll get a little bump in your pavement. So you want to keep that paving machine continuously at this consistent speed, ensure that you get a really flat, good surface. Here, now the key thing is that you're going to do your micro texture. Here, there's an initial burlap drag of that. This is the back end of the material. The concrete's extruded out the back. This is the front end. You'll see the concrete has been placed, even on top of the dowels here, where you'll get the machine driving over top of that. And because they're pinned to the subgrade, you won't get that moving, moving your dowel baskets. Now for consolidation, you're going to be following OPSS 350 again, slipform pavers. You're going to have the sufficient, as I had mentioned earlier, sufficient vibrators placed at the right depth for the pavement that you're being consolidating and the right vibration. Ensure you don't get vibrator trails because you have to have them too tight, up too high, and you'll get complete consolidation of that pavement and you'll get a very good, smooth, well-performing concrete pavement. Now you'll see finishing here, you'll see that burlap drag originally. Then this guy has got a bowl float, so he's smoothing out that concrete. Then there's a highway scraping straight edge that's taking all the high points and then filling in the low points to make sure that you have a very smooth concrete pavement surface. So next, when you're doing your timing, texturing, you're going to have that longitudinal drag. So there was an initial one, but because they bowl floated and they did the straight edge, you're doing an additional drag to get that micro texture maximized to ensure that you have a good, safe concrete pavement. And then you're going to do the texturing. You're going to put your tining on it. I like longitudinal tining. Transverse tining is okay, but it's a little bit noisier, and especially if you go deep. If they put the tining on when the concrete's a little has not gained as much strength, and it might go a little deeper, so you're going to increase your noise level. Your OPSS spec gives you the specifications on your transfer screws, what you're supposed to be. It's the same as the specification for the fixed form paving. And curing, you've got your curing process. They actually have automated systems where they spray the curing compound as soon as the your texturing is completed. They've got their timing done. That curing compound is placed to ensure that you keep that moisture into the pavement. Now you notice here that they will have to come back. The guy has those handheld devices that they pump up and they spray the curing compound on the sides of the concrete. Because again, you're going to keep that moisture content in there to get complete hydration of your cement and gain that strength that you're looking for. Cutting joints, very important because concrete is at its greatest size when it's being placed. As it loses that moisture through evaporation, you'll have the concrete will want to shrink. So you'll actually have to cut joints if you don't want random cracking occurring. Usually they're within the first 6 to 12 hours of cutting the joints, unless you use an early entry saw where you can actually go in within 1 to 2 hours. But you have to look at that type of saw and see if you want to use the early entry saws. They're actually very efficient, and you see those in a lot of jobs now. So you see the cutting, and it's a great cut here. So your concrete's going to crack right here. So you forcing the crack to develop in the location that you want directly over the dowel baskets that you've placed. Again, in Slipform, same thing. You've saw cut your joints to ensure that you have a good timing in that. You want to make sure, again, to see here the tie bars or space skip so that you don't have a locked up joint here. Now, what's critical too is if when you're cutting these joints, you get some random cracking occurring in front of the saw, leapfrog those joints. Go 3 joints down, relieve the stress in the pavement, go another 3 joints down, release that stress. Then once you've released that stress, you can go back in and do those intermediate joints, and you'll prevent any cracking occurring. So here's some timing. If you go in too early when the concrete's still green and you haven't used an early entry saw, you're going to get raveling or spalling at the joint because the strength of the paste is less than the strength of the aggregate itself, and the aggregates will pop out. So you want to prevent that from happening. So here's a too early a sign, and this is great sawing done at the appropriate time. Opening to traffic. See here, these lanes, this lane was done. This might have been a weekend work, and they opened it up closed it down Friday, opened it up on the Monday. I don't know for sure on this job, but you can see that you can open up the traffic, and then you can work on your other lane. And OPSS 350 states that you shall be at 20 MPa prior to opening it up to traffic, but when it's hit the 20 MPa, you can actually allow your heavier vehicles on top of it. So they're operating the vehicles in this lane now that was paved, and now they're going to be operating in this lane here. And finally, the lane painting. The line painting, what you want to do is you want to, if you would like to highlight things a little bit better, I always like to see a layer of black paint placed first, and then you place your orange paint here or your yellow paint, and then you place your white paint over top of that. It gives you a very good delineation because concrete is a much lighter color than asphalt. It actually just provides that better delineation on your line painting. Now, one key thing you have to do when you're doing your line painting is you want to sandblast off your curing compound to make sure that you get a good bond between the paint and the concrete. So you'd sandblast the area, place your black strip first, and then you'd place your white paint next to delineate that line. And that's it.
That's great, Tim. Excellent presentation. We do have just a few minutes for questions, so we'll pull up just a few questions. So the first question, would you recommend the use of fibers for concrete pavements?
Fibers, yes, they can be used as long as the fibers are distributed well within the concrete mix. They're very good. You can decrease the thickness of your pavement to a degree. You'd have to do an analysis of what additional strength of fibers give you. It just adds another thing in your mix design to potentially complicate things, I guess, but the jobs I've seen have performed well. You just have to make sure you don't have that balling of the fibers in your pavement. So you really have to make sure that they're distributed very well throughout the mix.
Yep, great. And just one last question. Is the 100% compaction of the granular layer relative to standard Proctor or modified Proctor density?
It's the standard Proctor. If I remember correctly, OPSS uses the standard Proctor. Modified Proctor is actually additional compaction. The only issue I have with the modified Proctor test is sometimes you have to pound the aggregate so hard you might actually fracture your aggregates. But you have to follow whichever spec is being stated. And in the OPSS spec, it does not say modified Proctor.
Okay. Thank you very much, team. Again, that was fantastic. Great overview of municipal concrete paving. So what's next in terms of our webinar series? We're quite excited for July 8th. So Tim and I will be back.
Thank you.
And we have invited Ben McWade, the project manager of construction management for the region of Durham. Ben was a key factor in getting Harwood and Bailey built, which is a pilot project, a major intersection reconstruction in Ajax. So Ben has agreed to provide you an overview, so you don't just have the concrete and cement guy talking about concrete pavements, but you will get the municipal aspect. We'll ask Ben, why they chose concrete, what did he learn using concrete pavements, and in terms of maintenance, what has been done so far. This webinar will be again limited to 100 participants, so make sure you sign up as soon as possible. We did sell out very quickly. And here's just a picture comparison. On the left side, 2016 Harwood and Bailey. You can see the rutting, the shoving, the distortion of the line painting. I was on the site, and the crossing guards were actually saying how they're tripping over it every day back in 2016, and they wanted something done. So luckily, Ben and the region were able to address it. So again, thank you very much, Tim. Thank you very much for everybody for attending this morning, and hopefully we'll see you in July for the next webinar. Take care and have a great day.
Thank you, Alan. Take care, everybody. Be safe.